G'day, thanks for watching this video on the Pickaxe Proto platform, and we're going to be soldering together today the starter platform. This is one of the first boards that I think most people will be using with this motherboard from the Pickaxe Proto platform family. We're going to need our same tools: pointy nose pliers, side cutters, component bending tool, some solder, soldering iron, and a little vise if you've got one. I did a bit of a demo on soldering in the first video for the motherboard, so if you're not sure on how to solder, then go and watch that video first. This one I'm just going to show you how to actually assemble the board, and we'll try and do that quite quickly. So this is what we're going to be making, and we'll have a look what's in our kit. So open up that kit, check out all of our parts. So we've got our board, obviously, some male header pins. Now those male header pins can be replaced with female header pins from the website. If you'd like to buy that, make sure when you purchase the starter platform you let me know that you want this to be a stackable unit, so that they can actually stack on top of each other like the Arduino stuff, rather than just having one platform on there at the time. Otherwise this could just be on top of another one that was stacked at the bottom, depending on what application you want it to work with. So we've got our 3 lots of 330 ohm resistors, 2 10k resistors, 1 1k resistor, 3 LEDs, push button switch, piezo buzzer. This little device looks a bit like a transistor, is a temperature sensor. It's called a TMP 36, and our LDR, our light dependent resistor. So this one we'll talk about in some programming, but we'll be able to see some light values depending on how much light's in the surface of that on our microcontroller. So we'll get started by again putting in the resistors first. I bend all these at the same time, so I'll leave the paper on, bend all those leads down, bend all those leads down, take it off and trim away those leads. Like I said in my previous video, I make sure all of the colour bands are facing up, so I put all the, well, not necessarily up, but always the same direction so it's easy to read. I'm going to put all the orange bands at the top, but resistors don't have a polarity, so that doesn't matter. So the 3 straight up there, and I might semi-clinch them now. And I'll cut them as well, so you can cut 3 in the same direction and then turn it around, cut 3 more. I won't solder them just yet, I'll keep on putting the resistors in. So bend them down. And you need to have a look on the instructions, because I've just changed the layout of this board a little bit. So this is version 1, there's a version 2 coming out, but I haven't got it manufactured yet. You'll see that it's missing an R2, so I've replaced, I think, R4 with R2 or something like that, and changed the values of those 3 resistors under there. So it will be in the same location, but those numbers will be a little bit different, so I won't use the resistor numbers. This one's the 10k resistor. It goes down the very bottom of the board underneath the switch, and that's pulling the switch down to 0, the 0 rail. Another 10k, face it the same direction, and that's the same thing. That's acting as a potential divider for the LDR. And then we'll grab the 1k resistor, cut that one first, bend it with the component bending tool. Now if you don't have a component bending tool but you've got a MakerBot, I saw that on Thingiverse today there was a component bending tool on there, so you can grab that, print it out, Otherwise, I'd definitely go down the electronics store and buy one, because it comes in pretty handy, and make sure that all your resistors are bent nice and neatly rather than just guessing. Right, with all my resistors in, I might start soldering, so I'll put that in my little vise. Just bring my fan over a little bit further, and I only need to be soldering the holes, obviously, that have the resistors in them. Be careful that you don't solder any that don't have resistors in them, because you have to suck that solder out to be able to put your other components in otherwise. There we go. Make sure you keep your soldering iron nice and clean with some sort of a scourer or a wet sponge, whatever method you use. All those resistors are in nice and tight, not going anywhere. Next we might put in the LDR, because that's sort of a resistor as well. It doesn't have a polarity, it can go either direction, because it's only a resistor, it can go in either direction. Drop that straight down. I put it all the way down to the bottom of the board. If you want, you could leave it up a little bit higher, so you could put something underneath it. I have found that the power light from the motherboard, this one, that power light shines through the bottom of this PCB like that, and because it's right next to the LDR, it does affect the readings a little bit, so I put a little bit of blue tack on the back of that board, just so that the power light doesn't shine through and affect the readings if you're using this one straight on top of the motherboard. Drop that all the way down, or you could put something underneath it. I don't. Right, put all of our LEDs in. Now, it doesn't matter really what the order is, you can put these in a different order, but if you're using the code from my website, I recommend that you put the red at the top, the yellow then the green, so longer leg is positive, put that in first, red, yellow, green, and with the finger on the back of them, semi-clinching each of those leads. Resistor leads are a little bit fatter, so make sure you get safety glasses on, because they do sort of fling across the table a little bit. I'm trying to show you what I'm doing on the video, but if I was doing this myself, I'd be pointing them down at the table so that they go straight to the table rather than shooting across the bench. Alright, and they are a bit wobbly, you can see that from the semi-clinching. So like before, if you just have it in your vise there, or whatever you've got to hold your board, and just solder one leg first, maybe you solder one leg on each of them, then go back and put your finger underneath it while you've got two hands now, and just reheat that joint and make sure the LED is pushed all the way to the top of the, or close as possible to the board, so they're nice and secure. And LDR over here. Done. Now we've got piezo buzzer, transducer maybe. Just need to bend the legs out a little bit. This particular buzzer doesn't quite fit that pin out, but it fits in alright, and it actually doesn't come out once you do push it in, so I reckon that's a pretty good position for it. Making sure that the positive's at the top of the board, just like the silk screen was, and we'll push the push button in as well. Now when the lead's going out to the sides, that goes left to right, and you can see that it only really fits in one direction. So push that down, and the little kink in the leads for the push button mean that it can't fall out, so we don't need to bend those leads. It just sits in there and sits all the way down to the board. Sorry, let's move the camera. So these legs or leads on the buzz are a little bit long, so you can cut them back afterwards, but the push button doesn't need to be cut at all, that's fine. You can solder each of them in. And like I was just saying, those legs are a little bit long, so you can cut them off after you've soldered them. We'll go for the temperature sensor now. If you prefer to do this accurately, you can just grab that middle lead in there and bend it out a little bit. So bend it out this direction first and then down, so it's sort of ready to fit in that hole. I find it a little bit easier just to find those sort of 3 holes and make sure you've got it in the right direction, so that the flat spot on it's located with that flat spot, and just bend the leads out until they locate those holes, and push it all the way down until it's maybe about 1.5 millimeters or 2 millimeters off the board, as far as it needs to go. I'll just bring that up to focus the camera. There we go, and you can see it's just off the board, it's not all the way down. This is the only component on the board that is going to potentially be damaged by heat, so you do need to be a bit careful soldering this one. Just like any microcontroller or any sort of a smart digital device, it's got some silicon inside it. It's best to sort of solder one leg at a time and give the device a little bit of time to cool down before you go and solder the next one. So rather than heating them all up at once, just do one leg at a time, give it a bit of time to sort of cool back down, come in and do the second leg. Again, give it some time, and a third. Alright, now all we've got left is these headers. That second row isn't really necessary on the starter board. I was just trying to be consistent with all the other boards that I've done, the same layout. But we just need to get the male headers and just poke them through so that the plastic's up against the PCB, and obviously these are coming out the bottom, and same as the motherboard. If I've only made a 5-way header because it fits into that 5-way female header, but that can go at the top, so there's one spare hole, and that's just for the future when we start using a 6-way header for the female on the motherboard. So same deal as before. You probably don't need to, you could just solder all of those in place, but I like to put it into that last board to make sure that they're all going to be nice and flat. It doesn't need to be in the vise anymore, it can just be on the ground, or the table, sorry. Solder one lead on each, so solder one here, one there, and one there, and just like the last video, then just go back and have a look and make sure you don't have any gaps between the PCB, or there's not any angles or anything wrong, that it's all lined up properly, and then you can go ahead and solder each of those pins from the top. And this is one of the reasons that the pads are actually on the top and the bottom of the PCB, not just the bottom, so that you can solder these male headers in from the top. And also later on, if you've got some wire lengths that you need to put between different pins on some of the more advanced boards, you can do that from the top or the bottom depending on where you've got room. Like I said, they're just on the starter board to give a bit of consistency. Probably won't use them on the starter board. clean off your soldering iron, and that's done. So if I turn that on now, without programming it the first time, it's still doing that flash, sending the serial information out the motherboard. Now, just a quick reference, that red LED is the power LED, tells you when the power's on, and the green one over here, it just tells you when information's being sent out through the second pin down, which is the serial out pin, out through this jack. So that's what that's indicating. So it's a bit of a diagnostic tool to use when we're doing some programming. And when we put it on the board, the red LED now is connected to that same green LED. They're connected to the same pin on the microcontroller, and there's no power LED on the starter platform. That's just flashing because it's connected to the leg that's sending that serial information out. So we'll turn that off and have a bit of a look at some programming with the starter platform and the motherboard. Thanks for watching.